Welcome to the mathematics in my channel. Today we are going to discuss about differentiation. This is lecture 2 of differentiation. So in this video we are going to talk about product rule and quotient rule and derivative of trigonometric function, also differentiation of exponential function. Okay, first we know if we take derivative of f of x, we know derivative of f of x, we can write f dash of x. Also, if we take the derivative of g of x, we know the derivative of g of x, we can write g dash of x. Okay, now we are going to talk about product rule. So d by dx. Now if we have to differentiate product of two functions, so f of x times g of x. Now we have product of two function, so this is the way to differentiate. So first rewrite first function, so f of x, rewrite first function, then take derivative of second function, so we know g dash of x, then here plus, then rewrite second function, so g of x, then derivative of first function, so f dash of x. Okay, this is the product rule of differentiation. So if we have a product of two function, we can apply product rule. Okay, now let's take some examples. So first one, d by dx, x to the third power x plus 1. Okay, now we have to differentiate product of two function, x cube times x plus 1. So according to product rule, we know first rewrite first function, so we know x cube, then derivative of second function, so x plus 1, derivative of x plus 1 we know 1, then plus, then rewrite second function, so x plus 1 times, then derivative of first function, so we know 3 times x square. Okay, this is the answer. Now second example. So if we take the derivative of x plus x square times 1 minus 3 times x plus x square. Okay, now according to product rule, we know first rewrite first function, so first function is x plus x square, then derivative of second function, we know 1 is a constant, so derivative of a constant we know 0, and here minus 3 times x, so minus 3, here plus derivative of x square, we know according to power rule 2 times x. Okay, then rewrite second function, so 1 minus 3 times x plus x square, and then here derivative of first function, we know derivative of x is equal to 1, plus according to power rule derivative of x square we know 2 times x. Okay, this is the derivative of this product of two function. So if you want, you can simplify this. Okay, this is the derivative. Okay, then third example. So if we take the derivative of square root of x plus x times x square plus 1 over x. Okay, now rewrite first function, so square root of x plus x, then derivative of second function, we know derivative of x square 2 times x, here plus, then derivative of 1 over x, so we know 1 over x minus 1 over x square. Okay, then here plus, then rewrite second function, so x square plus 1 over x times derivative of first function, we know if we have to differentiate square root function, we know 1 over 2 times square root, so 1 over 2 times square root of x plus derivative of x we know 1. Okay, this is the answer. So if we take another example, so d by dx derivative of x cube plus square root of x times e to the x. We didn't talk about the derivative of e to the x. So in the so we know derivative of e to the x. We will talk about e to the x differentiate. So we know this is e to the x, same function. So now we can write here first function, rewrite first function, so x cube plus square root of x. Now derivative of e to the x, we know e to the x, same function, then plus, then rewrite second function, then derivative of first function, we know x cube, so 3 times x square plus the square root function, we know 1 over 2 times the square root, same function. Okay, this is the answer for this question. Okay, now we talk about product rule. So then we are going to talk about quotient rule. So this is the formula. So if we take d by dx f of x over g of x. So this is the way to differentiate. First take square of the denominator, so we can write g of x square. Now here listen carefully. Now here first rewrite the denominator, so don't forget it. First rewrite the denominator, then derivative of numerator, so f dash of x, then here definitely minus. So in product rule we use plus sign, here minus sign, then rewrite the numerator, so f of x, then derivative of the denominator, so g dash of x. Well, this is the quotient rule of differentiation. So now we are going to talk about some examples. So if we take first one, the derivative of x square over x plus 6. Okay, now according to formula, we know first rewrite square of the denominator, so x plus 6 square. Now rewrite the denominator, so x plus 6. Now derivative of this function, so 2 times x, here minus. Now rewrite the numerator, so x square, then differentiation of the denominator, so x plus 6, so we know 1. Okay, this is the answer. Now second example, derivative of 1 minus x cube over 1 plus x cube. Okay, first we know the square of the denominator, so 1 plus x cube raised to the 2, and here now first rewrite the denominator, then derivative of this function, so minus 3 times x square, here definitely minus sign, and here now rewrite the numerator, so 1 minus x cube, then derivative of this function, so we know 3 times x square. Okay, this is the answer. Now third example, we have to differentiate e to the x over square root of x. Okay, now here we know the square of the denominator, so square root of x square, we know x. Now rewrite square root of x, then derivative of e to the x, we know here e to the x, then minus, then rewrite e to the x, then derivative of this function, we know 1 over 2 times square root of x. Okay, this is the answer. Now example number 4, derivative of 2x plus 1 over x to the 4th power plus x cube. Okay, then we know first square of the denominator, so x to the 4th power plus x cube all square, and rewrite x to the fourth power plus x cube, then derivative of this function we know 2, then minus, then rewrite 2x plus 1, then derivative of this function we know 4 times x to the third power plus 3 times x square. Okay, this is the answer. Well, now we talked about first we talked about product rule, then we talked about quotient rule, then we are going to talk about differentiation of trigonometric function. So first if we take derivative of sine of x, we know derivative of sine of x is equal to cosine of x, then derivative of cosine of x, we know derivative of cosine of x minus sine of x, then derivative of tangent of x, we know secant square of x, then derivative of cosecant of x, we know derivative of cosecant of x is equal to minus cosecant of x cot of x. Well, then the derivative of secant of x, we know secant of x tan of x, then derivative of cotangent of x, we know this is equal to minus cosecant square of x. Well, this is the differentiation of basic trigonometric formulas. Okay, you should remember these formulas. Okay, then we are going to talk about some examples. So first if we take the derivative of tan of x plus cosine of x, so we know tan of x, we know secant square of x minus here sine of x. Okay, this is the answer. Then second example, the derivative of sine of x times 3 plus cosine of x. Okay, now here we have, now look at carefully, now here product of two function, so we should apply product rule. So first rewrite first function, so sine of x, then derivative of second function, we know derivative of cosine of x minus sine of x, then here plus, then rewrite second function, so 3 plus cosine of x, then derivative of first function, we know cosine of x. Okay, this is the answer. Then third example, derivative of cosine of x minus sine of x. So here we know first derivative of cosine of x, we know minus sine of x, then here minus derivative of sine of x, we know cosine of x. Okay, this is the answer. Then example number 4, the derivative of secant of x over the square root of 5 minus sine of x. Well, now we have here secant of x over function, so this is like f of x over g of x, so we should apply quotient rule. So first we know the square of the denominator, so square root of 5 minus sine of x square, and rewrite the denominator, so square root of 5 minus sine of x, then derivative of the numerator, so we know secant of x tan of x, then minus, then rewrite numerator, so secant of x, then derivative of the numerator, we know minus cosine of x. Okay, this is the answer. Okay, now we talked about some examples of differentiation of trigonometric function. Okay, then we are going to talk about the differentiation of exponential function e to the x. So we know e to the x, if we differentiate e to the x, we will have same function, so e to the x. Okay, this is the formula for derivative of e to the x. So if we take the derivative of e to the function, so e to the f of x, so we know derivative of e to the fx, same function, so e to the f of x. But according to chain rule, in next lesson we talked about we are going to talk about chain rule, but here now I'm going to take this formula to solve some examples. So here e to the f of x, then derivative of this power, so we know f dash of x. Okay, this is the derivative of e to the f of x. So now if we take about some examples, so example number 1, derivative of 5 times e to the x. So we know here 5, so constant times, so we should rewrite constant, then derivative of e to the x, we know e to the x. Okay, this is the answer. Then second example, derivative of x times e to the x. Okay, then here we have product of two function. So we know if we have product of two function, we should apply product rule. So here rewrite first function, then differentiation of second function, so e to the x, plus rewrite second function e to the x, derivative of x, so 1. Okay, then example number 3, derivative of x square plus 1 times e to the x. Okay, now here also we have product of two function, so rewrite first function, then derivative of second function, we know also e to the x, plus now rewrite second function e to the x, then derivative of x square plus 1, we know 2 times x, yeah, only 2 times x. Okay, this is the answer. Now example number 4, derivative of x over e to the 2x plus 1, e to the here 2x plus 1. Now this is like f of x over g of x, so we should apply quotient rule. So first square of the denominator, so e to the 2x plus 1 all square, and rewrite the denominator, so e to the 2x plus 1 times derivative of the numerator, so 1, then minus, then rewrite the numerator, then derivative of the denominator, so e to the 2x plus 1. So e to the function, we know e to the same function, but according to chain rule we should multiply by derivative of 2 times x, so 2. Okay, this is the answer. Okay, now we talked about first product rule, then quotient rule, then derivative of trigonometric function, then derivative of exponential function. Okay, in next lecture we are going to talk about chain rule. So I hope to solve some examples of chain rule. Okay, if you like this video, please subscribe this channel. Thank you for watching.